Hello everyone, welcome back to yet another video from my channel Interactive Education, running for the best education possible from the student to the student. And today we're going to continue the exercise 8.4 from the class 10 mathematics chapter Introduction to Trigonometry. This is at page number 194, question number 5, exercise 8.4, and part 7 onwards, continuing from part number 6 as in the previous video on the same question. For that, please look that video up for the same. Like, share and subscribe to the channel as much as possible. Now we're going to look at these questions, the other questions which are left in parts left in this question of this exercise. It's a very important exercise, so as I've repeated before, I'm repeating again. So let's start off without further ado. The next question which we need to prove is that sine theta minus 2 sine cube theta by 2 cos cube theta minus cos theta is tan theta. Okay. So see here, you can say that the RHS is tan theta, which can directly be expressed as sine theta by cos theta, right? So if I can write the LHS directly as sine theta by cos theta by performing some calculations, I'll get my answer, right? So first of all, let's take whatever we can take common from numerator and denominator. If you take the LHS, it is sine theta minus 2 sine cube theta by 2 cos cube theta minus cos theta. Now take sine theta common from the numerator and cos theta common from the denominator, right? Let's do that quickly. So when we take sine theta common from here, we get 1 minus 2 sine square theta, right? By cos theta common, we get 2 cos square theta minus 1. Clear? Now this can be written as, now let's just simplify one of these. Clear? So if we actually let's simplify both. Now you know that one can be written as sine square theta plus cos square theta, right? Now just substitute this value of 1 in both the numerator and denominator. So if I can prove that this part is 1, I get directly sine theta by cos theta, and that will be the answer, right? So let's see if we can do that. So 1 can be written as sine square theta plus cos square theta, and this is minus 2 sine square theta, right? And here too, 1 can be written as, after this term 2 cos square theta minus 1, minus of sine square theta plus cos square theta. Clear? Now this can be written as sine theta by cos theta into sine square theta minus 2 sine square theta, so it becomes minus sine square theta. So cos square theta minus sine square theta, right? Divided by 2 cos square theta minus sine square theta, after opening the bracket, minus cos square theta. Clear? So this is equal to, now if you simplify the denominator also, you get sine theta by cos theta into cos square theta minus sine square theta by 2 cos square theta minus cos square theta. So you get cos square theta minus sine square theta. Right? These two get cancelled. Directly you get sine theta by cos theta. Now what is that? Nothing but tan theta, which is your RHS. Clear? So hence we have proved this first question. Clear? Clear with this part? Okay. Now from here, I would like to tell you something extra, right? Let us look at the second step. This is something which is out of your portion, but good for competitive examinations like Olympiads and all. So if you see here, you can say that when we simplify these two terms, ultimately they come equal to cos square theta minus sine square theta, right? As we got in this. So we can make an assumption, we can make an inference from here. You can infer that 1 minus 2 sine square theta is equal to 2 cos square theta minus 1. And you will learn in 11th standard that this is equal to nothing but cos 2 theta. You will learn that these two are both forms of cos 2 theta, and you will learn this in higher classes in 11th standard, that 1 minus 2 sine square theta is equal to 2 cos square theta minus 1, which is further equal to cos 2 theta. Clear? So if you know that identity, this can be directly done. These both are equal to the same thing, so they can be cancelled, sine theta by cos theta. But since that concept is not there in 10th NCERT, we are not doing that. We are simplifying it and finding the answer. Clear? Let's move on without further ado to the next part of this question, of this exercise, which is this. We need to prove that sine A plus cosec A whole square plus cos A plus sec A whole square is 7 plus tan square A plus cot square A. Now have a look at the LHS. It's a very simple thing. As you simplify, you'll go with the flow. So if you open the squares, you'll get sine square A plus cosec square A plus 2 sine A cosec A. 2 sine A cosec A. Plus open the square also, you get cos square A plus sec square A plus 2 cos A sec A. 2 cos A sec A. Now sine square A plus cos square A is 1. So I am taking these two terms and writing 1. That's an identity. Now sine A cosec A. You know that cosec A is equal to 1 by sine A. And sec A is equal to 1 by cos A. That's it. So sec A into cos A will be 1 and cosec A into sine A will also be 1. So these two terms can be written as 1. So you get 2 into 1 plus from this term again 2 into 1. So these two terms 2 into 1 and 2 into 1 plus what is left? Cosec square A plus sec square A. Clear? So this is equal to 5 because this is 2 plus 2 4 plus 1 5 plus cosec square A plus sec square A. Now you know two more identities. You know that cosec square A is equal to 1 plus cot square A. And you also know that sec square A is equal to 1 plus tan square A. Clear? So substitute these values here. You get 5 plus cosec square A can be written as 1 plus cot square A. And why am I writing like this? Can you think? Yes, because the RHS has these two terms. So it's better we include them. Plus 1 plus tan square A. That's it. 5 plus 1 6. 6 plus 1 7. So you get 7 plus tan square A plus cot square A, and this is nothing but our RHS, as you can see. Hence proved. Clear? Simple way of proving, easy way of proving, direct, without any complications. As we simplify, as we go with the flow, you get the answer. Clear? Now let us move on to the third part of this question, which is this. A bit difficult, a bit tricky. Cosec A minus sine A into sec A minus cos A is equal to 1 by tan A plus cot A. Now see here, look at this question carefully. I had discussed one question previously, in this one part of this question previously, and I had said that in that part you have to simplify the LHS and RHS separately. Remember in the previous video. Here too that same case applies. You can see that the right hand side is only tan A and cot A, and it is very difficult to express cosec A, sin A, sec A, cos A as tan A and cot A only. Clear? So you will have to simplify LHS and RHS separately. Clear? Simplify LHS and RHS separately in this case. So first of all, look at LHS. LHS is cosec A minus sin A into sec A minus cos A. Sec A minus cos A. Now multiply. Cosec A into sec A will be cosec A sec A. And this into cos A will be minus cosec A cos A. Minus sin A into sec A. Plus, because minus minus plus, sin A cos A. Now very carefully look at these terms. You know that cosec A is 1 by sin A. Right? I had written this here as well. Cosec A is 1 by sin A and sec A is 1 by cos A. Clear? So substitute these here. You will get cosec A is 1 by sin A, sec A is 1 by cos A, minus cosec A is 1 by sin A into cos A, minus sin A into 1 by cos A plus sin A cos A. Clear? Now 1 by sin A cos A. This is 1 by sin A into cos A. So this is nothing but cos A by sin A. And what is cos A by sin A value? Cot A. So this can be written as minus cot A. Because cos A by sin A, 1 by sin A into cos A is nothing but cos A by sin A. That is cot A. Minus sin A into 1 by cos A. That is sin A by cos A. And that is tan A. Plus sin A cos A. Clear? Now write these two terms together. So you get 1 by sin A cos A plus sin A cos A minus, now this can be written as cos A by sin A. Leave it like that, I would say, right? Because everywhere we have sin and cos, so it's better you leave it like that. Cos A by sin A plus sin A by cos A. Because I've taken the minus outside and we've kept this in a bracket, I can write plus. Clear? So now write all the terms with the LCM. So you get sin A cos A as the LCM, right? So this is 1 plus 1 into sin A cos A. So this into sin A cos A will be sin square A cos square A. Clear? Minus sin A into cos A. So this is cos square A and in bracket plus cos A into sin A. So this is sin square A. Clear? So you know that cos square A plus sin square A is 1, right? So this is 1 plus sin square A cos square A minus 1 by sin A cos A. And that is simple. This 1 and 1 gets cancelled. You can get sin square A by cos square A, where sin A cos A is nothing but sin A cos A. Now this is the simplified version of LHS, equation 1. Clear? So simplified version of LHS is sin A cos A. Now have a look at the RHS. The RHS is 1 by tan A plus cot A. So RHS now. RHS is 1 by tan A plus cot A. So this can be written as, again in terms of sin and cos, because we've got the simplified version in terms of sin and cos, we will simplify the RHS also in terms of sin and cos. So we will get tan A is sin A by cos A plus cot A as cos A by sin A. Now this is what? Now take the LCM again. So sin A by cos A comes in the numerator. If you see sin A by cos, sin A cos A. So you can see, let's do it stepwise. So this is sin square A plus cos square A by sin A cos A. Because you're taking LCM, which is sin A cos A and cos A into sin A. So sin square A here plus sin A into cos A, so cos square A here. Now sin square A plus cos square A is 1, clear? But this sin A cos A moves here. Clear? Because it's in the denominator, so this goes in the numerator. So you get sin A cos A by sin square A plus cos square A is 1. So directly you get sin A cos A. Clear? Look at this as equation 2. Now the simplified version of RHS is sin A cos A. But wait, the simplified version of the LHS is also sin A cos A. Clear? Hence you can say from 1 and 2, LHS is equal to RHS equal to sin A cos A. Hence we have proved the given identity. So clear with this part? I hope it's absolutely clear to you. This is how we simplify this question. You have to go stepwise and simplify LHS and RHS separately in this particular question. Clear? So I hope that's absolutely clear. So with this we have concluded this part of this lecture, this part of this question, these 3 parts of this question, part 7, 8 and 9. In the next video on this question of this exercise, we will be looking at the last question, which is a bit tricky, but if you get the logic, it's very simple. So it's a bit long and tricky, so I'm making a separate video on it. So please look forward to that video. I hope you like this video. Any comments and suggestions are welcome in the comment section below. So stay healthy, stay smart, do keep studying, and I hope you're enjoying this series on Introduction to Trigonometry. Thank you very much. Goodbye and stay smart.